So last time we spent maybe like 3 or 4 minutes just kind of introing this, and I think where we kind of landed at the end there was to basically say that this table is telling us some information about C of t, and then it goes on to ask us about C prime of t, right? And it almost seems like they're asking about the wrong thing because they gave you information about C, and then it's like, well, tell me when, is it possible for C prime to equal 2 on that interval? And so that's kind of where we finished. And I think at the end I said something like, how do we connect C prime with the table that has to do with C? Like, what's the connection there, Peyton?
Oh, can I answer? Can I
Peyton? Oh, sure. You can ask a question. You can answer. Yeah.
Okay. This is a shot in the dark, but we find what is effectively the secant line by finding the average change in water.
Secant line slope, right?
Yeah, secant line slope.
Secant line slope, okay.
And if that is above 2, then at one point it has to be 2.
If it's above 2,
Maybe below.
then at one point, okay, so when he says at one point above 2 and then another point below 2, what kind of thinking is that?
Intermediate.
It's intermediate value theorem, right? So I think we can, I think that's feasible. That's very feasible, but I think there's an easier way. I am going to use a secant line slope, I think, but we'll approach it just from a slightly different angle. But I think your thinking could be workable, possibly. Let's see here. Possibly. I'm going to use instead of an IVT idea, I'm going to use an MVT idea. But maybe we can still explore what you're talking about. I'm going to try to show the most efficient way. Okay. But Peyton definitely touched on some really important ideas there. Maybe the most important of which is maybe we could use a secant line slope, because isn't C prime describing the slope of C? So if you've got a table like this, remember the saying is if you can't differentiate, that's fine. Just use the slope of the secant line. And so I'm going to use the slope of the secant line on the interval that Peyton mentioned, the interval from 2 to 4. And I'm going to see what this just comes out to be and go from there. So let's try this out. I'm going to say C prime is approximately equal to, and I'll use that secant line slope on this interval, the one that was mentioned. So it's going to be the change in C divided by the change in time. And if you do the math here, 12.8 minus 4.8 is 4. 4 minus 2 is 2. And you get 2. Okay, so this is where I think the MVT comes into play. What's basically happened here, if you're going to trace this back to our police speed trap exercise, haven't the police now found the average speed of the driver? Like, that's the average rate of change. We know for this case, the average rate of change of amount of coffee is 2, right? 2 ounces per minute, I suppose, would be the units there. So 2. So if we know that the average rate of change is 2, then don't we know that somewhere on that interval the instantaneous rate of change has to also be 2? That's that MVT thinking, or the speed trap thinking. But all that reasoning hangs up on one set of conditions. Bless you. What's the set of conditions?
Continuous and differentiable.
Yeah, it's got to be continuous and differentiable on this interval. And do we know that that's true?
Yes.
Yeah, doesn't it come right out and more or less say it? It says that C is differentiable. So we could say something like this, because C is differentiable, C is continuous. Okay, so C is differentiable means C is continuous. Therefore, the MVT applies. Morning. And because, I'll put it like this, the average rate of change of C equals 2, C prime has to equal 2 at least, that'll fit there, at least once on the interval from 2 to 4. Is that not the police's reasoning, right? They said, We know you averaged 50, therefore we know you went 50 somewhere on the interval, because we're assuming that your car doesn't teleport. So because we know that this is a differentiable and continuous function, we know the MVT applies, so that means we hit the average rate of change somewhere on the interval. Does that make sense? Okay, we'll keep trying to draw that back to that police exercise just because that was hands-on. Obviously this has to do with coffee, which I don't know what that has to do with police, but hopefully you get the overall principle. So I'd like to maybe real briefly talk about Peyton's original idea, and let's see if this would have worked out. You almost could have used an IVT thought process here, perhaps. What we could have done is we could have looked at the average rate of change between those two data points. So 11.2 minus 8.8 would be 2.4, right? Am I doing that math in my head right? I think so. Yeah, 2.4. So the average rate of change there would be 2.4 over 1. And then here, the difference, see here, the average rate of change would be 12.8 minus 11.2, which is 1.6 over 1. So C prime went from 2.4 to 1.6. And because C is differentiable, means that C prime is continuous. Therefore, because of the IVT, I think that we'd have to pass through 2, right? Because 2.4 is bigger than 2 and 1.8 or 1.6 is less than 2, we'd have to go through 2. So I think you could have used that line of reasoning as well. I chose to do this because we're talking about the MVT.
When I was saying the slope of the secant line, if it's above 2, I was assuming it wasn't going to be exactly 2.
Mm-hmm.
So if it were above 2, then you would know it would also at one point be 2.
Well, no, if it's just above 2, that's not enough. To show, just because something is above 2 doesn't mean that it was 2, right?
Oh, okay.
So you'd have to show
Using the police car thing with it, because they're saying it was at least like 55.
well, of course, for their, we
Yeah.
had observations that they were below. So if they were below and then averaged above, we know that they had to, hit that average, yeah. But this, if you know that you got a C prime less than 2 and a C prime above 2 because of the continuity of C prime, you've got to hit 2 somewhere in
So
between.
if that slope of the secant line wasn't 2, you couldn't, you could say...
You couldn't use MVT. You couldn't use MVT. You might be able to use IVT. This was set up to work nicely with MVT.
So
obviously.
if it works out perfectly, you can use it.
In a case like this, sure. Yep. Otherwise, if the data in the table just doesn't work out as beautifully as we want, you might have to use an IVT concept. But here the MVT was nice. Hopefully I'll set it up in the way that I intend for it to work out. Yeah. Okay. Good deal.